Statement of Ellerey Parser. Believe me, I would rather have consulted with Parker Jacob 3 years ago, instead of testifying today. Maybe then I could have helped prevent the tragic events of May 18, 2019. Those events were foreseeable to anyone who has taken the time to learn about human behavior and the predictable ways that people interact with their world. That is what I do in my profession as a human factors consultant and analyst. Human factors experts study the effects of people's mental, perceptual, and physical capabilities and limitations on their contacts with stimuli from other parts of the environment. Working with engineers and architects, human factors professionals design and build efficient and safe machines, roads and trails and other structures. These experts also help create instructional materials and warnings that help users minimize the risks they must encounter. Scientists in this field have spent decades researching topics such as perception, attention and distraction, learning and memory, fatigue, and risk perception. They apply this in many ways, including casework involving the operation of products and equipment, roadway, retail, and recreational environments, educational brochures and alert design. After the fact, forensic human factors analysts are frequently retained to evaluate the actions of individuals within particular environments and to determine whether the people responsible for creating these environments properly took human behavior into account. The field of human factors and ergonomics, a related discipline, is broad. A human factors expert may have an undergraduate degree in a field such as engineering or architecture or design, as well as a graduate degree. Other experts who emphasize research and analysis may study psychology or physiology. My work needs to be distinguished from that of a safety expert. This term encompasses many different backgrounds. There is a national certification, a CSP certificate that stands for Certified Safety Professionals. According to the Board of Certified Safety Professionals, CSP, its members are people who perform at least 50% of professional-level safety duties, including making worksite assessments to determine risks, assessing potential hazards and controls, evaluating risks and hazard control measures, investigating incidents, maintaining and evaluating incident and loss records, and preparing emergency response plans. I am not a certified safety professional. My educational background is comprised of a Bachelor of Arts in Psychology from Indiana Western University and a master's degree in ergonomics from the University of Central Utah. For a number of years, I have been self-employed as a consultant. As you would expect given my background in ergonomics, most of my consulting work involves safety concerns in human-created workplaces. Unfortunately, owners of businesses and attractions tied to the natural environment seldom seek professional advice about the conditions on their premises. This is only the second time I have been asked to review a situation of this type, and the first time I will be testifying about whether a resort owner breached the standard of care by failing to account for human factors in its outdoor operations. However, the principles that will be discussed are universal, so I feel comfortable expressing my opinions. My fees for investigation, preparation and review are $200 per hour, and the same rate applies to time spent in authoring a statement or testifying. Because the preparation in this case required me to travel to a remote area to view the conditions, I have already incurred $6,500 in fees and costs. My opinion is not affected by the amount or payment of my fees. In preparation for testimony, I have reviewed the statements of the witnesses and viewed the location where this accident occurred, including the trailhead and the portion of the ski area and trail depicted in Exhibits 1 through 3. This visit occurred in the spring of 2021, approximately 2 years after the accident occurred. I understand that a new culvert was installed at the trail location and that the large drop in the trail has been replaced by a more gradual downhill. At the ski slope corner, a newer model snow cannon had been installed. It seemed pretty loud when the crew started it up for me, although I do not know how it compares to the sound of the snow cannon depicted in Exhibit 4. I could not find this model to listen to during startup or operation. In any event, any minor differences in sound would be irrelevant to my conclusions. Finally, the trailhead signs depicted in Exhibit 6 have been replaced with more extensive, detailed signs. I was not asked to determine whether the current signs were adequate, and there were 5 or 6 of them, so I didn't review them in any detail. In my opinion, the owners of Extreme Ski and Sport Resort failed to adequately account for the human characteristics of their trail users in three crucial respects in their operations on May 18, 2019 and did, in each instance, fall below the standard of care of a reasonably prudent person. First, the condition of the approach to the hole in the trail failed to provide adequate stopping sight distance for a hazard of this type, given the anticipated speed of trail users. Second, the operation of a loud snow cannon just above the trail, with accompanying precipitation, without adequate shielding, failed to account for the startle reflex this would produce in individuals near the trail hazard. Finally, trail signage in existence on May 18, 2019 was inadequate to warn trail users of the specific hazard of the precipitous drop-off, so that these users could adjust their speeds and activities to adequately meet this danger. Before I discuss these conclusions, let me say that I did not reach them simply because an accident which led to injury occurred on the trail. As Anthony Hidden observed in his 1988 report on the Chapman Junction Railway accident, there is almost no human action or decision that cannot be made to look flawed and less sensible in the misleading light of hindsight. Even the most carefully thought out and planned activity can result in loss to the foolish and the careless. But the conditions here made it much more likely that even a cautious trail consumer would be injured, because people act predictably in given situations. Failure to anticipate this expected behavior and to take steps to address it forms the basis for my opinions. First, I will discuss the approach to the hazard that faced Nikki Kulshin in this case, the precipitous drop into the hole. Please note, my opinion is not that it falls below the standard of care for a trail to be maintained with a drop of this type. Some users might actually enjoy the challenge of working around an obstacle of this sort. It's not my cup of tea, but to all their own. No, the problem here was the approach to the drop, which did not allow even a cautious user to see the hazard in time to either stop and go down the switchback trail, or to build up sufficient speed to attempt a jump over the obstacle. In order to appreciate the reasons for my opinion, let me take a few moments to discuss the factors that go into sight distance calculations. Adequate sight distance is required to provide a path, sidewalk or roadway user the opportunity to see and react to the unexpected. Stopping sight distance, the number of feet required for a user to come to a complete stop, is a function of the user's perception and brake reaction time, initial speed, the coefficient of friction between the user's wheels and the surface, and the braking ability of the user's device. In this case, we are dealing with a crest vertical curve, where a shared use path goes uphill and then drops off. Because the drop-off does not protrude above the trail, its edge should be treated as a crossing trail and the stopping distance needed for this type of situation is applicable. The minimum stopping distance for a crest vertical curve is a function of the algebraic difference in the uphill and downhill grades, the assumed height of an object on the pavement, and the user's A height. The Green Book of the American Association of State Highway and Transportation Officials gives equations for calculating the minimum length of a crest vertical curve so that adequate sight distance is available. The equations assume wet, paved surfaces. The surface here would arguably require a longer stopping distance, although the user would probably be traveling at a slower average speed. Using the AASHTO formula, the minimum stopping sight distance for this curve would be 67 feet on wet pavement. The sight distance was obtained by calculating the distance traveled during the perception reaction time, using an assumed speed of 15 miles per hour, to the calculated braking distance under wet pavement conditions. The A height of the cyclist is an average based on numerous studies and an obstacle height of 0. The uphill grade here was 5%. The actual stopping sight distance for this location was 49 feet, well short of what was needed. The distance is calculated for 85% of users, so the trail is not safe for most of the cyclists who would approach the drop. I did not try to match the calculations to Kulshin's actions, because that would not excuse the construction of an unsafe trail. A reasonably prudent landowner would maintain the area so that at least 85% of cyclists could safely stop before reaching the edge. Extreme Resort did not comply with this standard. My second opinion is that the Extreme Resort owners were negligent in their unshielded operation of a loud machine that sprays cold water just above this dangerous section of trail. This operation triggers the startle response that all vertebrates naturally display. The startle response is a reflex-based sensor motor physical reaction that is elicited by any startle eliciting stimulus. such as a puff of air or a burst of noise, we can habituate ourselves to minimal, expected or anticipated sounds or events, and these do not affect our performance of tasks, such as driving. But unusual, loud stimuli will cause all of us to blink, wince, jerk and otherwise become distracted and to change our actions immediately after the stimulus is applied. In some cases, this distraction can be used to our advantage. For example, the installation of rumble strips on the edge lines and center lines of roadways is designed to slightly startle the driver. The sound and vibration divert the driver from his or her prior inattentive behavior and redirects attention to the driving task. But large startling events almost always cause negative distraction from operation tasks, causing operators to divert their attention away from safe operation of a vehicle. In my opinion, that is exactly what occurred here. Assuming that a sudden burst of loud noise, accompanied by a shower of frigid water and ice, occurred just before caution approached the drop-off, these stimuli would have distracted the plaintiff from the trail ahead and prevented the plaintiff from reacting to the hazard. A prudent operator would either delay starting the snow cannon until the trail near the hazard was clear, or would build shielding around the device to block the moisture and muffle the sound. Of course, I am not an engineer, so I do not know what shielding would be effective or how practical, from a cost standpoint, it would be to install such a guard. I suspect the more practical approach here would be to assure that the trail was clear before starting the device finally. Let me comment on the third deficiency in extreme resorts operations, the adequacy of its signage on this trail after the decision was made to leave the drop in place. The most critical prerequisite for any effective warning sign is that it gains a person's attention at a critical time. Elements such as location of the warning, type, size and font, and color are important in this regard. Good warning format includes the following: 1. An alert symbol, exclamation point with a triangle, followed by an appropriate signal word and color background, i.e. red danger, orange warning, and yellow caution. 2. Condensed verbiage describing a. The nature and severity of the hazard, b. The consequence of exposure, c. Action to be taken to avoid the hazard, and sometimes, d. Procedure to treat exposures. Since people are unlikely to read lengthy text, brevity and comprehension become critical. Pictorials often are desirable and complete sentences are unnecessary here, but the wording must be explicit and tied to the danger. In this case, the signs depicted in Exhibit 6 are too general and too far from the hazard to provide an effective warning. Some aspects of this sign are consistent with good practice, the use of bright yellow and the repeated reference to caution, but the reference to difficult and dangerous terrain is in the muted brown sign, immediately below an innocuous pictorial of a hiker. While some contrast between signs is helpful in drawing attention, everything should not be the same color. Danger language should be highlighted and more explicitly tied to bikers and other trail users. In addition, a trail sign describing the specific hazard of the drop-off ahead should have been located about 75 to 100 feet from the hazard itself. Let me be clear, every bump and dip in a primitive trail does not need to be signed, but this drop is sufficiently dangerous to require a more explicit warning. That would allow a biker who is paying attention and moving at an appropriate speed the necessary time to stop and to avoid the hazard. I would note that I do not know whether the plaintiff in this case would have noticed such a sign or taken appropriate action. I do not know caution's speed, and I was not asked to opine on the plaintiff's actions and whether those actions met an appropriate standard of care. That is outside my area of expertise. My conclusions are based on the anticipated reactions of most humans, not the specific reaction of the particular human involved in this incident.